Hello, good morning, everybody. Yeah, apologies, I'm 4 minutes late. Exactly 4 minutes late. 240 seconds late. Welcome to Math with Isaiah. And I hope you all had a great night rest yesterday. I'm not sure I did because I didn't really sleep at night. Very recently, I've made it my business not to do much sleeping that night because if you're my age, you should learn to cut your sleep. Because one of the things I found out is we're so busy during the day. Sometimes the only time we have is actually the night, and you still have to make some investments. So you have to cut your sleep. Sometimes you sleep just 2 hours, sometimes 3 hours, so you can maximize whatever is there. Alright. So today, okay, I think I gave an assignment yesterday that I said I was going to attend to. Let me see if I can find it. Okay, at the end of the class, we'll attend to that. But very quickly, let's move to today's topic. Today, this is day 3. So day 3 of our 14 days. What do we call it? 14 days live session. So today, we're looking at expansion. We're looking at factorization. Of algebraic functions. So like I said, expansion and factorization of algebraic functions. This is a topic that I never learned. I just knew it. Okay, I have a few questions here that we can use to quickly get through this. One second. Alright, so when you say, okay, these are algebraic functions, where you have something like this, 7 into bracket 2x plus 7. So this is an algebraic function. Now what you're basically saying here, expansion, expand this thing. Let's put it here, expand. So basically what they're asking you to do is expand this. We do not want to see this bracket anymore. Destroy the bracket. So that's basically what we're asked to do. Now, this is an example, and let me see if I can find another example. Let me come up with something in my head. Let's say you have x minus 2 into 2x plus 7. Now look at this. They are saying to expand this, and they are saying to expand this. Expand. Now here we have two different variables, but just one here. Now how do you expand these two? Now the technique behind it is different. Now this, for instance, whenever you want to expand this, whatever is in the bracket remains constant. So you multiply whatever is in the bracket by whatever is outside the bracket. So we have to multiply this with this, and then we have to multiply this with this. So you'll be having this 7 times 2x, you have 14x, 7 times 7, sorry, 49, mistake. Now, that's how you expand something like this. If you have just one figure on the outside, then you have to multiply that figure by this, right? Individually, you multiply them. Now, most people, whenever they want to teach you this is how they will teach you to do it. Look at this. they tell you to do this. But I don't really like long journey. So they tell you to do this 7 into bracket 2x plus 7 into bracket 7. Are you seeing the idea behind this? You're splitting this for both of them. So 7 times this, 7 times this. I don't know if you get. That's how you come about with this. But this is long journey. Just go ahead and multiply directly. This times this times this. You get your answer directly. Instead of going through all of this stress. Now, but when what you have is something like this, before we go there, imagine something like this. Okay, let's take use the same example. You have x minus 7 into bracket 2x plus 7. I'm trying to explain all of the common mistakes in the mathematics. When you have something like this, okay. Let's not rush it. We'll explain that. Let's touch this. Now you have 2 variables here, 2 variables here. How do you expand something like this? Now in this scenario, this first variable multiply these 2 variables, then this second variable will multiply these 2 variables. This will remain constant. It's this one that will be multiplying. This will multiply these 2, this will multiply these 2. So you have something like this equals x times 2x. You'll be having 2, now x times x. Remember what we did in the indices. That's the thing about mathematics. Everything is interwoven. There's maths in algebra, and there's indices in algebra. There's simultaneous equation in matrices. It's all interwoven. So if you don't start from the basics, that's why we're all beginning from here. Now x times x. We have the same base, so you invisible power of 1. There is 1 here, there is 1 here. Pick one of the x's. 1 plus 1, you have x raised to power 2. I hope you understand. Now x times 7. There you have 7x. Now we've multiplied this and these 2. This times this, this times this. Now moving to the next variable now. Remember, this 2, this minus belongs to this 2. So we're doing minus 2 times these 2 variables here. Now minus 2 times 2. Minus times, let me see if I can write that somewhere here. Minus times minus is plus. Plus times plus. Plus. Plus times minus. Minus. Minus times plus. I'm sure some of us know all this already, but just in case. Now, there is no sign here, so we know it's plus right here. Minus times plus is minus. So we're having 2 times 2x, 4x. Then now this again times this. Minus times plus, we have minus. 2 times 7, we have 14. I hope this is clear now. So this is how you expand something like this. Now if you look here, 7x, 4x, we can actually add these 2 together. That will take us into factorization, but I will explain that later. But just know that this is 2x squared minus 7x plus 4x. Sorry, 7x minus 4x rather is 3x plus 3x and minus 14. So now that's that about that. Oh, give me a second. Let me get the system close to myself so I can see. I have a few questions. I'm actually going through my Alright, so if you do have any questions, just type them in the comments and I will attend to them. Alright, so let's move further. I hope this is clear. Let's do one more. Let's do one more example. Or not one or two. One or two. So yeah. Alright. So one more example. Okay, so what we're going to do is we'll do one example of expansion, one example of factorization, one example of expansion, one example of this. So now, let's do factorization now. Now factorize this. Factorize 3y plus 12. The thing about mathematics for me is that I like it. I like the dynamics around it. It's not easy. So it's not something everybody likes, and I like it. I don't really like doing common things like that. Alright. Now when you say factorize, the root word for this is factor. You can see it here. So when you say factor, you mean we're looking for something inside something. Like when you put two things together now, you say factorize, it means what's common between them? Let's find the factor that's common between them. So when you say factorize this and this, now what do you think is common in this? What can you bring out of here that is also here? Now if you look at this, you see that there's 3 here, there's 3 inside 12. Meaning if you divide 12 by 3, meaning you can see 3 in 12 4 times. Let me explain. Let me just write the answer. If you look at this, if you divide this by 3, you have this. You can remove 3 from this. How many 3s can you remove from here? 4. 3, 6, 9, 12. You can remove 3 from here 4 times. That's what factorizing is. We're looking for something that is here and also here. So 3 is in here once, 3 is in here 1 time, 3 is in here 4 times. So this is how you factorize this. Okay, I said I was going to do just one example of each, but let's do one more of this. Okay, a question. Okay, let's factorize 12m plus 8m squared. How do you factorize this? What is common? Let's look at the numbers. What do you think is common? Is 2 common? Yes. 2 is here 6 times. 2 is here 4 times. Now let's do it first. 2 6m plus 4m. 4m squared. Do they still have something in common? Yes. That same 2 is still common. So that means we were wrong. The answer is not supposed to be 2. It should be 4. 4 is here. 4 is here. How many 4s do you see here? 3, right? 3m. Now look here. How many 4s do you see here? 2. 2m squared. Do they still have something in common? Yes, m. That means we were wrong. It's not 4 alone, it's 4m. Keep using my hand to clean this, it's not healthy. Now it's 4m. How many 4m's are we going to see here? 3. M is going to be out of the picture because m appeared here once and it's already here. Now how many 4m are we going to get from here? That's going to be 2. How many m is here? We have 2 m's, just 1. So if you're removing 1, you're left with 1. 2m. Now this is correct because now there's nothing again that you can remove from it. So this is how you factorize this. So this is what they mean by factorization, and the last thing we did was expansion. So this is how you factorize and expand algebraic functions or algebraic expressions. Let's do a few more examples. Let me cancel this. Yeah. So that's actually how it works. It's not so hard. But the thing about mathematics is that, like I said, everything is interwoven. One is inside the other. That's how it works. Now let's look at this. I found a sweet question. 5a squared b plus 15ab squared. Now they said factorize this. 5a squared b plus 15ab squared. How are we supposed to factorize this? Now, what's common? 5 is common. 5 is common. 5 is common. You take that out, 5. Because you see 5 in here 3 times. You see 5 in here once. Now looking at A. A is common. Is here once. Is here twice. Looking at B. B is common as well. You take B. Then you now open the bracket. Now that we have this, we can't put 5 again because 5 is out. A, we still have one more A, so you put it here. B, you can't put B again, is out. So all that will be left here is A. Plus 5 out of 15 is 3, right? No more A. A is gone. Then B, only one B is going to be left. This is how you factorize. This is the factorization of this. I hope you understand. So yeah, factorization is not really hard like that. Now when you factorize something, you get this. When you expand, you get this. Because this now, remember what I taught you about expansion. This multiplied by this multiplied by this. If you do it, you get this back. Let's try it. 5ab times this. Now, you can only multiply the a there because that's the only thing that we have in common here. It's something like this: 5a raised to the power 1, a raised to the power 1 times a raised to the power 1. It's only a that has something in common. So you're having 5 a raised to the power 1. Because of this, you have plus 1 and b raised to the power 1. So you're having 5a raised to the power 2 b. So you have 5 and b can multiply, only the a. So you're having 5a squared b, which is exactly what you have here. And then if you do the same thing for this, you come up with the same thing again, 15ab squared. So when you factorize something, you get an expression that you can expand and get the original content. So that's the relationship between both of them. So you expand the factorized to get the original, if you get what I'm saying. Yeah, so that is that about expansion. Let's quickly do more of those double, something like this. Let me clear this. Something like this. 6 minus 2b, 5 plus 2a. Let's expand this. Remember what I said. This is multiplying this, and each is multiplying both. So this times this times this times this times this. It's now understood. Now, let's go. 6 times 5, 30. 6 times 2a is what? 6 times 2 is 12. And you have 8. Now we move to this. This negative sign is for this. Minus times plus, we have minus. 2a times b, that's 10b. Minus 2b times this. We're having minus times plus is minus 4ab. This is your answer. So this is how you expand something like this. It's as basic as that. It's not, honestly, it's not hard. I assure you, it's not hard. I'd like you to keep this though, but I have a trick on how I do this. If they are the same sign, just know it's plus. Minus minus is plus. Plus plus is plus. If they're the same, if you're multiplying the same sign, you can definitely get plus. But if one is different, it's negative. That's my trick around. I don't trick anymore. I've been doing it for so long. I know it's of half. Alright, so yeah, that's basically how you expand. Let me see if I can give some assignment. Okay, let's quickly do one solving before we are done. Now we have this. So 2 into bracket W minus 4 equals 13. Now this is not an algebraic expression, this is an algebraic function. Sorry, an algebraic equation rather. What makes an equation is this equal sign. That is what makes an equation. Once you see the equal sign, it becomes an equation. Because you are equating things. The word equal, equate, equal, equates, equation. So once you see the equal sign, that thing becomes an equation. It could be a polynomial equation, it could be a quadratic equation, it could be a linear equation. But once this sign is there, you have an equation. Now this is an equation. All the ones we've been doing before, they were expressions. There's no equation there. So now this is an equation. Now the first thing to do is to expand this, right? This times this times this. What do you have? 2w, this times this, minus 8. See that I expanded it very quickly. This times this times this. Quickly. It's not hard at all. Equals 13. I'm sure a number of us knows how to solve this, so I'm not going to want to waste my time here. Normally, people say collect like terms here, but I don't really have that kind of time. So just show this over here. We have 2w, and mind you, whenever a particular variable wants to fly over the equal sign, the symbol behind it changes. If you have plus here, it becomes minus here. If it's minus here, it becomes plus here. So this 2w equals, this comes here, 13 plus 8. So you have 2w equals 21. Then here, because you're equating, you divide both sides by 2. Sure, we all know that 4 over 2 equals 21 over 2. So you have w equals 10.5. As simple as that. Yeah. Let me see if I can find one last one. So we're literally moving gently. Okay, I can see one question there. We'll do 2 more and we'll call it a day.